One of the common methods that we might use in remote sensing for looking at the Earth's surface is to look at multi-temporal changes. If we collect satellite images over time, we can look at a number of properties to do with the Earth's surface and how they change. Radar systems have a particular advantage over optical systems in this regard because we can see through clouds and we can also see in the nighttime side of the orbit. Then we're guaranteed coverage on every pass, both in the daytime and the nighttime, and whether there's clouds or not. Over short periods of time, so for example over a year, so over the collection of the seasons, we might use the multi-temporal data to explore the growth properties in agriculture, or we may be looking at the seasonal effects over forested vegetation areas. And over 1 year, we can do that to look at land classification, because some areas, like forest, may change significantly less than areas of agriculture, and urban areas may not show any change whatsoever. So by looking at the quantity of change over a year, we might be able to classify the land cover type as a means of extracting more information out of the remotely sensed data by collecting it together over a long period of time. Beyond a year, so over many years, we can also use that same data to look at long-term changes in land cover. Deforestation would be one particular example where you might look over long periods of time to see the changes in forest cover. Now that we have got longer and longer data sets from satellite-based systems, we have near global coverage going back many decades. In the optical domain, we've got data from the Landsat from the 1970s. For radar images, we've got data from 91 onwards in C-band data. And then in other wavelengths, we've got a number of different data sets that will go back a few decades.